Hey guys, Mr. Canister here with another video. Today we're going to look at velocity versus time graphs and try to solve them in a few different ways. One of the things we've been talking about during class is how there's lots of different ways to solve physics problems. So we're going to take a graph problem. I'm going to show you three different ways to solve it so you can use that during class. So let's consider the following question. Using the following velocity versus time graph, determine the distance the object travels in 5 seconds. So if we take a look at the graph first off, you note that as time goes on, the object is speeding up. We're going to figure out how far the object moves using three different ways. So first way, we can find the area. So one of the things we learned in class is the area underneath the velocity versus time graph represents the distance or displacement. So because this is a triangle, the area of a triangle is 1/2 base times height. The base of the triangle is 5 seconds, and the height of the triangle is 50 meters per second. Taking the area then and doing the math, we get 1/2 of 5 times 50, and we get 125 meters. And so, just simply by taking the area, we find that the object travels 125 meters in 5 seconds. All right, the next way we can solve this problem is using that graph, we can find the acceleration of the object and then use our kinematics equations to solve the problem. So there's actually two ways to find the acceleration from this graph. I'm going to pull the graph over so we can see it. The first way we can do is we can use the slope of the graph to find the acceleration. Recall from class that the slope of a velocity versus time graph is the acceleration. So slope is defined as rise divided by run. So an arbitrary rise, if we take this point and this point, the rise of the graph is it goes 50 minus 0 divided by the run, which is 5 minus 0. And so we get a slope of 50 divided by 5, or an acceleration of 10 meters per second squared. With that, we can now use some equations to solve this problem. So for example, I could use the equation vf squared equals vi squared plus 2ad to solve this problem. That's just simply one equation you could use. I'll use my final velocity, which was 50, my initial velocity, which was 0, should be a plus. And again, you see the same math kind of taking place. When you go ahead and perform the math, you get, again, the same distance, 125 meters. Another way to solve this problem as well is, instead of using the slope to find the acceleration, we could simply use another kinematics equation to find the acceleration. The one that I like to use a lot is v final equals velocity initial plus acceleration times time, where we just simply pick again our two data points. Any two would work, plug it into the equation and solve. So for example, to solve for the acceleration in this problem, I could take my v final, which is 50, my v initial, which is 0, plus the acceleration times the time, which is 5 seconds, and again, perform the same math to get an acceleration of 10 meters per second squared. So you can see here, there's two ways to solve for the acceleration, one being the slope, and one just simply plugging in numbers from the graph to find the acceleration, and then solve. The final way, which we haven't talked about too much in class, but it's a really useful way for solving these problems, is you can just simply find the average speed of the object from 0 to 5 seconds, and then use the average speed equation. So recall, the average speed of an object is defined as the distance it travels divided by time. So how do we find the average speed? Well, the final velocity was 50 meters per second. The initial velocity was 0 meters per second. And so the average speed is the final velocity plus the initial velocity, simply divided by 2. And so we get an average velocity of 25 meters per second. Now, when we use the average speed equation, we go ahead and use this as our average speed. So we write the equation down, v bar equals d over t. We plug in 25 meters per second equals distance divided by the time, which was 5 seconds. And then again, cross-multiplying, we see that the distance again comes out to be 125 meters. So the average speed equation, you got to be careful that you actually calculate the average speed correctly, but it ends up being a really simple, useful way to solve these kinematics problems, especially when you're accelerating. Well, I hope that helped you out, and now you have three different ways to solve velocity versus time problem. Thanks.